What are the correct energy definitions for COP in thermodynamics? Have you ever wondered how efficient your refrigerator really is? Or how heat pumps manage to keep your home warm in winter? The answer lies in a concept known as the coefficient of performance, often abbreviated as COP. This term is essential in understanding the efficiency of thermodynamic systems like heat engines and refrigerators. The coefficient of performance is a simple yet powerful measure. It tells us how much useful energy we get out compared to the energy we put in. For heat pumps, the COP is calculated by taking the amount of heat delivered to the warm space and dividing it by the work input needed to operate the system. This can be expressed as COP for heating equals heat delivered divided by work input. On the other hand, when we look at refrigerators or air conditioners, the COP changes slightly. Here, it is the ratio of heat removed from the cold space to the work input required. So, we can say that COP for cooling equals heat removed divided by work input. Both of these calculations give us a dimensionless ratio. This means that the units of heat and work, like joules or kilowatt hours, cancel each other out. This is why the coefficient of performance can often be greater than 1. Heat pumps, for example, can deliver more heat energy than the electrical energy they consume by extracting heat from the environment. From a thermodynamic standpoint, the maximum theoretical COP depends on the temperatures of the hot and cold reservoirs involved. For ideal systems that operate reversibly, we can use specific formulas. For heat pumps, the maximum COP can be calculated as the hot reservoir temperature divided by the difference between the hot and cold reservoir temperatures. For refrigerators or air conditioners, the maximum COP is the cold reservoir temperature divided by the same temperature difference. These formulas reveal an interesting fact. The closer the two temperatures are, the higher the possible COP. This indicates that heat transfer becomes easier when the temperature difference is small. In real-world applications, however, the actual COP is usually lower than the theoretical maximum. This is due to various system losses and inefficiencies that occur during operation. To summarize, the coefficient of performance is a key metric for evaluating the efficiency of heating and cooling systems. It relates useful heat energy output to work energy input. Understanding this concept helps in making informed choices about energy-saving technologies in buildings and refrigeration. So next time you turn on your air conditioner or heat pump, you can appreciate the science behind its efficiency.